Let's simulate the fluid flow over an inclined plane by creating an external fluid domain, which is commonly used to find the aerodynamic forces or drag forces, etc., in a aerodynamic study of aerofoils, vehicles, etc. So let's create a simple inclined plane to run the simulation. So click on new, control new, then the part name should be inclined plane. Click on OK. Just check the unit, which is millimeter Newton second still. So go to front plane and go to extrude to create that inclined plane. So let me create a simple inclined plane like this. Let it be 300 millimeter and height 150. Just click on OK. Then make it symmetry and it will be 300. Right. So this will be our inclined plane. That means this inclined plane is assumed to be moving forward to this direction in opposite of x direction with a velocity of, let's say, 1 meter per second. So I need to find the drag force which is pulling backward, and I need to show the streamlines of flow over the body. Right. So go to applications and flow analysis, and let's jump to wizard. Create a project. Let me name it as an external flow, any name. Okay, click on OK. So I'll be finding the flow, and there will be some turbulence, so I need to find the streamline. Click on next. Do you want to set gravity force? You can go for it, or you can leave it as no. Do you want to create a fluid domain? Yes, and it should be an external fluid domain, so click on external. Now we need to show the domain from this module. Go to domains and select solid component. That means the domain should be, the fluid domain should be as par with the part, that means our inclined plane. So click on add solid component and select this part. You can select the part from the model tree itself. You can see that inclined plane. So click on inclined plane, and to create the fluid domain, just right click on the model. Okay, on the workspace, just right click. Now you can see the fluid domain. That means the domain which is under consideration of fluid flow calculation. And I need to place the bottom surface of the object onto the base of the fluid domain. So select the box margins and change it from uniform to non-uniform. That means I'm going to change the values. So in the y direction, the object should be on the base. So select the y direction and let it be 0. You can see that right at the bottom only. Top surface I'm keeping as it is at 0.5 value, and in the sideways also the domain is pretty big. I can reduce the size for our analysis. So in the z direction, let it be 2 in one side, okay, and in the other side as well, let it be 2. Now it is okay for our fluid analysis. Click on OK, then go to next, which is asking for the fluid flow material. Let it be air. Click on next. Are there any inlet boundaries? Yes, that means the part is moving forward, so click on yes. This front facing plane will be the inlet, so select any of the plane. This is the back side, so again click on that. Yes, this will be our inlet flow, right? So click on OK, next, and just set the flow parameter. Let it be the part is moving with a velocity of 1 meter per second, and I'm not taking the release streamlines because this inlet face is not the streamline, and I'm going to produce a streamline from the body itself, not from the inlet plane. So click on yes, next. Are there any outlet boundaries? Yes, that means except the front plane, all the other planes are exposed to atmosphere. So select every planes, this one, not the second one, it is the inlet, and this one, this side. Oh, the bottom face is also not required, so deselect that, this side one and this one also, right? These are the outlet, that means these planes are exposed to the atmosphere. So let's say it will be specified pressure outlet, so we can assign the pressure of atmosphere 101325 pascal, right? Then click on next. Do you want to specify other surface to apply boundary condition? No. So do you want to set any other volume parameters? No. It's a transient? No, it's a steady state flow. And for the mesh generation, let it be a default settings and ready to generate mesh. Now it is generating the mesh. It's completed. Now you can see the fluid domain, and part is inside the fluid domain itself. So to plot the boundaries output, select the boundaries and click on next, and select the boundary for output parameter settings. And I need to find the parameters just like uh, the pressure, force and all on the body itself. So I'm selecting the object inclined plane body, then click on next. And what I need to plot is I need the pressure force in Newton, viscous force. I'm not dealing with that. So click on next, right? So the pressure force is the output. Pressure force is x, y, z direction, and the body is moving in the x direction. So I need to find the x direction pressure force. So let it be the plot 1. Click on finish. Do you want to run simulation? Yes. So let's wait to complete the simulation. You can see that the run button is now deactivated. That means the simulation is running in background. Now the simulation is complete. You can see that the pressure variation is very less, just because the part is very small and the moving velocity also is very small. So the pressure variation from the blue to the darker one, right? But it's not visible just because the body is in the fluid domain. To view the fluid domain and the body, just go to the section view, and the section plane is now selected as plane X. I need the section plane with respect to the Z plane, so select Z plane, right? Then click on next, and I need to see the pressure. That's good, right? Then click on OK. Now you can see the pressure variation from the starting point to the end point, right? Now the second aim is to find the streamlines from the body itself. I need to show the streamline, and let me create the animation of the flow from the body itself. So to select that, go to boundary condition and go to general boundaries. Now you can see the default part, that means our inclined body itself. So this part uh, should be the source of streamlines. To create that, go to the view model tab below, and at the bottom you can see that an option for streamline, release particle. Now in default it is no. We need to create streamlines from this default part itself, right? Then go to view, and which one I need to show the velocity. Let's say the velocity of the part, velocity of the streamline, right? And to view the streamline, scroll down, go to streamline, and click on this streamline, right? Now you can see the streamline, that means the path of the flow particles, and the color will shows the velocity, right? So select this no selection to velocity if you want to show the velocity. Yes. you can see the velocity of air flowing and the direction as well. If you want to animate the flow, just go to model. The animation time size is 0. Let it be a non-zero value. This one. Now you can see that the animation, the fluid flow is passing, and the velocity magnitude is ranging from 0 to 1.243 meter per second, right?